Hello everyone, it's Mr. Sutherland, and today we are going to start section 8.3, which is looking at a different form of a quadratic equation. And we're going to look at a quadratic equation that is in standard form. So if you have the ability to print these notes out from the assignment sheet so you can fill them in as we go, that would be great. If you can't, you can just write down the important information in your notebook. But what we're looking at here is a quadratic that is in standard form. So it's not in vertex anymore. We don't have those parentheses. And it's, all right, if it's in standard form like this, how do we find the axis of symmetry? How do we find the vertex? How do we find the y-intercept? So if we look at standard form of a function, when it's a quadratic, there are these letters here. So the first letter, that's our a value still. The second letter is our b value. And the third letter is, or the third number is our c value. So if we want to find the y-intercept for a quadratic that's in standard form, it's very simple, because if we make x 0, if we plug 0 in for x, this goes away, we're just left with 5. We're just left with whatever the c value is, and that's what we have up here. Now, to find the axis of symmetry, which remember is the x-coordinate of the vertex, it goes through that. So our axis of symmetry, if I were to underline this in our picture over here, or that's that vertical line that cuts our graph in half, and it goes through the x-coordinate of the vertex. To find that, what this says you're going to do is you get a negative. You do the opposite of what the b value is, and then you divide by 2 times the a value. So in our example down here, the b value is 8. I do the opposite of 8, and I go over 2 times the a value, which is 2, and that gave us negative 2. So that means the axis of symmetry is at x equals negative 2. To get the vertex, what we now do is we know whatever the axis of symmetry is, that's the x-coordinate of the vertex. To get the y-coordinate of the vertex, we take that value, negative 2, and we plug it in for x. So we would do 2 times negative 2 squared plus 8 times negative 2 plus 5. And that gives us our vertex of 2, negative 3. So the main thing to remember here, the big idea, is that when we want to find the axis of symmetry, we're going to do x equals the opposite of the b value over 2 times the a value. So here at the top of the notes is just a reminder. This one with all the letters can be confusing to look at. That's why I think the example underneath kind of walks you through how to do one. So in the rest of the notes, we have one example here we're going to do together. And then what I would like you to do is there are 2 problems on the back I'd like you to try on your own. Okay, so we'll start with this first problem. So we've got f of x equals 2x squared plus 4x plus 3. And I want you to find the axis of symmetry, the coordinates of the vertex, and then the y-intercept, and we'll sketch a graph. So for the axis of symmetry, it is always x equals the opposite of b over 2 times the a value. So when I go to my equation up here, remember this is still the a value. The a value is always with the x squared. This is the b value. This is the c value. So the 2 is a, b is 4, and c is 3. So I've got x equals the opposite of b, so negative 4, over 2 times the a value, which is 2. Now we just calculate that. So that is negative 4 over 2 times 2 is 4. So we get the axis of symmetry to be x equals negative 1. So I'm going to go to my graph over here, and x equals negative 1. I'm going to draw a vertical line for my axis of symmetry. x equals -1. Now, for the vertex. Well, we know already that -1 is the x-coordinate of the vertex. So what we do now is we write our function. So f of x equals 2x squared plus 4x plus 3. And now we're going to plug in -1 for x. And now what I would do is just use a calculator. You can get one online or on your phone, or if you have your calculator, that would be great. And put all of this into your calculator. And what you're going to get when you do that is, let's see, this would be 2 minus 4 is -2 plus 1 plus 3 is 1. So this, the 1, is the y-coordinate of the vertex. So our vertex, the x-coordinate is -1, the y-coordinate is +1. So I've got -1, +1, and I put a point. Oh, that's in the wrong spot. I'm sorry. We'll go over here and do -1, +1. There we go. Now the y-intercept. The y-intercept, everyone, is the easiest part when it's in standard form. The y-intercept is always whatever the c value is. So our y-intercept for this graph is 0, 3. So I go to 0, 3. And we have our parabola. Well, we have a couple points here. Now, in order to sketch this, the a value is +2. I know this opens up, so I'm just going to put this half going this way, and then remember the idea of symmetry points. I can put another point over here and get our graph going up. And now we could see, if I asked you what is the range of this graph, I got my y values, my smallest y value. Here's my vertex at -1, 1. My y value of the vertex is 1, and all my other y values are bigger than that. So we have our axis of symmetry, we have our vertex, and we have our y-intercept. So what I would like you to do is, on the back of this worksheet, there are 2 problems. Pause the video and try those 2 problems. And when you're done, unpause the video and then check and see how you did. Okay, so everybody should have tried those problems now. So the first thing I do, you don't have to use different colors. I've got A, B, and C. So my axis of symmetry is at the opposite of B over 2A. So the opposite, so -2 over 2 times the A value, and the A value is -1. So I get -2 over -2, which gives me x equals 1. So this one has an axis of symmetry at x equals 1. All right, for the vertex, we know the x-coordinate of the vertex is at 1. To find the y-coordinate of the vertex, we take our function, and I'm going to plug 1 in for x this time. So that gives me, let me change this. So we plugged 1 in for x. And so that gives me -1 plus 2 plus 8. So f of 1 is equal to 9. So I get the vertex to be at 1, 9. For the y-intercept, I take my equation, f of x equals -1x squared plus 2x plus 8. And remember, if I make x 0, the only thing that's left is, this is the only thing that doesn't have an x, so that's my y-intercept at 0, 8. So my a value is negative. This is definitely a parabola that opens down. And then I can put another point over there with symmetry and kind of draw a parabola opening down. So hopefully you did well on that problem. Here's all the information for it. All right, last problem. So axis of symmetry is that x equals opposite of b over 2a. So I've got -6 over 2 times 3, because again, this is a, This is B, this is C. So I end up with negative 6 over 6, which is negative 1. So here is our axis of symmetry at x equals negative 1. Now to get the y-coordinate of the vertex, because we know the x-coordinate is negative 1 already, I plug negative 1 everywhere I see an x in my function. So that gives me 3 minus 6 plus 5. And so I believe 3 minus 6 is negative 3. Plus 5 would be 2. So I get that the y-coordinate of the vertex is at 2. This is a parabola that opens up because a is positive 3. And the y-intercept, we take our equation, and the y-intercept happens when x is 0. And so again, the only thing without an x is the 5. So I've got 0, 5. And then I just go to the other side here, get my symmetry point, and we have our parabola. And we can go back for these parabolas, and now we can find the range for each one. So if I look at number 2, for instance, for the range of this one, because we know the domain is always all real numbers. That never changes. The range is what changes. I have the range, I have a y value of 9. That's the largest possible y value. So all my other y values are smaller. For 3, we have our vertex was at negative 1, 2. So the y-coordinate of the vertex is here at 2. And so when I do the range for this one, all my y values, it's opening up, all my other y values are bigger than 2. So the focus of today, let me go back to the very front, is given a parabola, a quadratic equation in standard form, in order to find the vertex, we have to do a little work. We have to use this formula, opposite of b over 2a. Then once you have that, you can then find the y-coordinate of the vertex and the axis of symmetry and sketch a graph of your parabola. I hope this helps, and if you need any more clarification, do not hesitate to email me. Try the homework. You can always contact myself or Mrs. Musa for help. Take care, everyone. Bye.